And I think we're good. We'll just wait another minute before we get started. So feel free to take notes. I encourage you to take notes. I think, you know, this is a long class, so it's good to be active, but I think being active helps students retain information, and there's been a lot of studies done on that, and that's what they're finding. So let's get started. And I'm going to start with some announcements. I want to look at Canvas a bit. I want to look at ALEKS a bit before we get into ALEKS topics. Test 1 is 2 weeks from this Thursday. It's on 9/24. We have about a test a month. You know, school starts in August. We've got September, October, November, December. We have about a test a month. So that makes sense. Quadratic equations objective is due this Thursday. And we just have a bit more, like 2 or 3 more topics to finish in there. And they are among the simpler topics. So I think we've done the challenging ones already. And then we also have radical equations objective is due this Sunday, and we're for sure going to start that objective today. So let's first go to Canvas. So let's see over here. I want to look at Canvas for a bit. I want to go into the student view because I want to make sure we're seeing what you're going to see. So let's just start. I did post an announcement. The syllabus says you're required or you're responsible for the content of all Canvas announcements. And I think I sent you all an email through Canvas about this particular announcement. Where to go for help. So let's start there. And I'm going to click on the magnifying glass so I don't download it to my computer. I have so many things on my computer. I really need to take the time to clean it up. So, where to go for help? Ann Bear's virtual office hours. How do we get there? We go to Canvas. When you scroll down, note the virtual office hours in Teams. So let's do that. Let's go ahead and do that so you can see. So, I'm going to go back out and enter again. Whoops, it didn't let me do that. It didn't let me do that in student view. So let me go out of student view for a second. Okay, I'll go back into student view, I promise you. Okay, so I'm going to go back into Canvas. I'm going to enter. I'm going to go to student view. I'm going to scroll down. So that's what it's saying. The first page you come into Canvas on is called the home page. So on the home page, it's saying you scroll down on the home page, and there are my virtual office hours. This is the link that you want to click on for virtual office hours. It's not the same as the meeting you're in right now. I have more than one class, ALEKS class, and I have the office hours for them at the same time. So today's office hours are at Tuesday from 2 to 3, right after our class. I have office hours. So I got to hop out of our class pretty quickly after class just to get into my office hours, but you're welcome to get into Canvas and join those office hours with me if you have more questions after class. I just have to start that by 3 o'clock. So that's where you would go to see what my virtual office hours are for this class. And also this last link at the bottom is the one for virtual office hours. This link at the top is the one for our class that you're in now, or near the top. So just beware. there are two different links, one for the class meeting and one for virtual, and a separate one for virtual office hours. So we were looking at this in the announcement, where to go for help. So let's go back to that. Click on it again. Video links to Ann Bear's class recordings. Go to Canvas, click on modules on the left side. Click on video links. Okay, so that's what we want to do. So let's do that. So let me leave the student view for a moment and go back in just to show you. So let's do it. Let's start from scratch so you can see how I did it. So I'm going to go back up here, go to the home page, do student view, and I want to find the video links, modules. Click on modules. So when you enter Canvas, you're going to be right on this page. Go click on modules. Video links. There they are. There are all our videos. Links. There are links to all of those. Look, links to all of our videos. So that will hopefully help you. Now let's go back down to announcements here. Where to go for help. Look at this. I'm going through this document. Ann Bear's class notes. So Ann Bear's class notes, let's go into Alex. Go to the main menu in Alex. So I've got my Alex up over here. Go to the main menu. So I go to class tools, student view. You don't do this. I need to do it though. We'll get that working for us. And what is it that we need to do? Class notes, go to the main menu in Alex. Instructor resources, objective notes. Oops. Let's see. Okay. So let's go to Alex, and we want to go to the main menu and then instructor resources. The main menu, these three horizontal bars. Instructor resources. Objective notes, and there they are. And I even have them in here for all the objectives that are going to be covered on the first test. So I've got everything in here. So if you want to work ahead, feel free. Got my class notes right here. Now, before we leave the main menu, I do want to point out, I made sure the calendar was perfect over the last few days. So I like to use, this calendar is on the main menu. I like to use the 2 weeks view. Well, you see within the next 2 weeks, so you're already seeing the test 1 review, no credit. I like to offer that assignment just in case you have not completed all the topics in every objective. This will really help you review for the test because you will find that your test the test 1, I will select from the topics in this test 1 review no credit assignment. So that's very important. It kind of, you know, makes it easier, less to be concerned with when it gets closer to test time. So let's just go forward another 2 weeks. And you can see here's test 1 on the 24th. So you want to take whatever vertical bar, you can look at this as a bar graph, I suppose, in a sense. You take this and have it go straight up to September 24th. And you can see that the objectives appear up here. So I wanted to like show you where my notes were. It's another resource you can use. I'm a firm believer in multiple resources because we don't all learn the same way. So the next item, how to email Ann Bear your exact ALEKS problem. So I will talk more about this in a bit, but I did want to say, if you just email me your exact ALEKS problem and you do not give me any more specific or any specific questions or tell me, you know, on the learning page, I got to step such and such, and then I had a question about that step, and the question is this, I'm likely going to point you back to, if you don't tell me any specifics, I'm likely going to point you back to to the office hours or to the class recordings or to the class notes. Because it's when you just say I don't understand a problem, I need a starting point. I need you to tell me, hey, I got to this step on the learning page and then I didn't understand the next step. Or I need you to tell me where in the notes you don't understand a problem from the same topic, or where in the video link do you not understand. So I really need you to help me pinpoint what your exact issue is, what your first exact issue is in the problem. And when you email me, you can also attach written work. So that is another way to show me where your exact problem is. If you send me a copy, if you attach your written work to the email, then I have something to work with that I am hopeful that I can pinpoint what your problem is so I know how to help you. Because if you just send me a question, a problem, I don't know where to help you any more than I've done in class with all the resources at that point. And I don't really want to do your ALEKS problems for you because I want you to, I want to guide you as you get stuck. I don't really want to do the entire problem for you because I don't want to give you the answers. I want you to come up with the answers on your own so that you will be better prepared for knowledge checks and better prepared for the exams. So this, if you click on this though, right at the very beginning, here, let me just start it from the beginning. We're not going to watch this, but it will start off by telling you how to do that. It goes into the main menu of ALEKS.
I would like to talk to you about main menu navigation in our ALEKS software. To access the main menu in ALEKS, we want to click on these 3 horizontal bars that are in the top left corner of the pie screen. Let's first talk about home. Home is what you want to click on if you want to get back to the pie screen. It will take us back to the pie screen. Learn is where you're actually going to learn your topics. ALEKS will often take you there automatically. So this is where you're learning your topics in learn mode.
I don't know if I want to go through the whole video here.
On this,
oh yeah.
If I click on this envelope here,
so right here,
it will pop up this screen, and it's taking a moment or two to load.
Right here is what we're looking at.
This will send me an exact snapshot of the problem you are working on. So what you want to do, though, is provide enough information so that I know exactly what your issue is. So you can type it in. You can even attach a file here. So you can write your work down on paper and then take a picture of it or scan it in and email it to me. Please provide me lots of detail as to where you're having your issue. So I'm going to click out of this and go back here.
So I'm just going to end it there, But that is a very good video that I created in the spring, this past spring. It doesn't apply if you see dates and due dates, it will not apply to this class, but there's a lot of very good ALEKS navigation information in that video. So let's go here. Let's look at click on this link, Math Center. So these links are good active links about the NWAC Math Center. So this is talking about in-person appointments up here. But let's look at this last part. Feel free to also email mathcenter@nwac.edu to set up an appointment for online math tutoring help. Specific questions are easier to help with, so please have specific examples or topic questions. So really, the Math Center is asking for the same thing I am asking for to you, is for you to be very specific about where you need help. So they're not, if you're going to be virtual, it's going to be really tough for them. You know, they're not going to be as inclined to write out an entire problem for you. They want to really try to get to the exact spot where you need the help. I would encourage you, rather than to use the Math Center, that you seek help from me. However, I have 6 classes this semester, and so I may not be unfortunately, I may not be available at a time when you are available. So that's why I'm making sure you have access to every resource that I can possibly think of that you may want access to. So let's go back to Canvas, and let me clean up my screen as I go. I have had a few students use BrainFuse in the past. It's free. Online tutoring is also available through BrainFuse. This option is found via your NWAC connection under Resources, Online Tutoring. So you will need to go into your My NWAC connection to access this. And this is how you access this. Now, you can chat with a live tutor during the following days' times, 5 p.m. to 11 p.m., and Saturday and Sunday, 1 p.m. to 11 p.m. So this is good if those hours are compatible with your schedule. However, I do know that I've had students use this in the past, and they will be given a tutor, and midway through that tutor helping the student through the problem, that tutor will leave and another tutor will come in right in the middle of the problem. So just keep that in mind. And that second tutor that comes in may not have the same approach as the first tutor. So I have heard that about, and I've actually looked at BrainFuse logs that my students have been involved in, and I've noticed that. So I just want to put that out there for you. And I want to say, if you use it, keep it in mind that this might occur. They may switch tutors on you mid-problem. NWAC IT Help Desk. Oh, I can't tell you how much the IT folks have helped all of us get through what we're going through now as a society with the pandemic. They have helped us tremendously. I don't know how those people are holding up because there aren't that many of them. But they're wonderful folks. They, can recommend technology if you need new technology. For instance, you will need a mic for the proctored testing that you will do in this class. And I know I've had an email from a student or two whose mic doesn't work on their laptop, but so if you need an external microphone, they can recommend one for you. They recommended technology for me this summer, and I'm a Mac person and have been for 10 years, but I wanted a Windows computer so I could write documentation for my students that have Windows computers. So they recommended one to me. They're also good if you have forgotten your NWAC login and or password. They're good for that. If you want to download any of the other Office products on your desktop, in addition to Microsoft Teams, they can help you with that. So there's a lot of good reasons to contact them. Alex Support. Now, the main place I've seen this support used is with students on test day. They have forgotten their login, Alex login, and or password. If you forget your Alex login and password, this is where you want to go. You want to call them. I've had students do this when we were in the classroom. They go out in the hall and call them and get it taken care of. So, and they are Johnny on the spot. So if that happens to you, please call them. So that's where you would go. Any questions on that on Canvas in general and what is there? So you will see me post within the next few days testing information, like how does the proctored testing work? And that I would post in an announcement and send you all an email that from Canvas that the announcement has been posted. So let me see. Do I want to do anything else? I think I've covered what I wanted to talk about before we get started with our current objective that we need to work on. Anybody have any questions? So let me just leave the student view, clean up as we go. Do I want to look at this? No, we looked at that. Let me just show you one more thing. Where the syllabus is, there's now a schedule that has every assignment on it in the entire class and when it's due. Okay? That's under announcements. Actually, sorry, it's under syllabus. It's under syllabus. I thought it would be nice to have the syllabus and the schedule together. So it's under syllabus. So it's right here. So don't forget to go to syllabus to look at that. But you don't have too much to look at, and you've just got your home screen that you enter on your syllabus, your modules, and your announcements, and that's it. So let me go back. Let me just close everything down. This. I like to keep everything clean, especially when I'm conducting a conference. What would happen if it did go late because I had class in the morning? Okay, so the problem with knowledge checks is you don't want to wait until the last possible. Okay, so Jacob, can you give me, when was the due date of it was due at 12 this morning? I believe, but don't quote me, I believe as long as you started that knowledge check by the due date, you would be able to finish it. Does that make sense, Jacob?
Yes, ma'am. Thank you.
Okay. Any other questions about the course in general before we get started? So let's get started. I believe we had a little bit left to do in the section on quadratic equations, so let's finish that up. But before I do that, just in case I forget to take attendance later, I'm going to take attendance now. So I'm going to take some screenshots. That should do. So let's talk about solving quadratic equations by using the square root property. So what we did last time was some of the more challenging topics. And I do definitely encourage you to all work on these objectives as soon after class as possible. Number one, you're probably going to remember more. Number two, it gives you more time to seek help on the topics you find them more the most challenging. So, and there's a lot of good research out there that if you write down your problems and keep a notebook of your problems and solutions, that you're more likely to retain the material. And I have had ALEKS students over the last few years, the ones that keep the biggest notebooks, I tell you, really tend to do the best in the course. So the biggest, neatest notebooks. And so I think that that's really, really good. And the knowledge checks, I would encourage you to study all for those knowledge checks as if they are a test, and I would treat them as a test, no notes. I had a student who did it the notes way, came up to me, and she said, I got a C on that first test, but I did it your way, and I studied for the next knowledge check. I studied for it just like it was a test, and she got an A on the second test. So it is very, very important, I think, to study for those knowledge checks like they're tests. Just a piece of advice and a confirmation from a student of mine. She was so excited that she got an A on the second test, and she ended up with an A in the course too, because I dropped the lowest test score of the first 3 tests. I cannot drop the comprehensive final. I would violate math department rules if I did that. And I'm not going to put my job on the line. So anyway, let's look here at solving quadratic equations by using the square root property. So what is the square root property? What does it say? It says if x squared equals a number, then how do we solve for x? X is plus or minus the square root of that number. So what undoes squaring? The square root. So you take the square root of both sides. Take the square root here, take the square root here. But remember, this 2 up here reminds us that there's quite possibly 2 different solutions. So we need to put a plus or minus with this side. And then remember, we also have the square root. So that's why this says x equals plus or minus the square root of k. So let's take a look at this problem. Solve y squared equals 64. This square on this y tells me there's likely 2 different solutions. You might get the same solution twice. Say you wanted to find the you wanted to solve y squared equals 0. Well, that one only has one solution, 0, but it actually occurs twice. So we're going to talk about numbers which occur multiple times later in the course. But in the case of a square root, you would then have y equals 0, or in the case of if you had y squared equals 0, there would only be one solution in this context, and it would be 0. But all other answers are either going to be no solution, because we're only talking about real numbers. And remember, a complex number involves I, the imaginary unit. And if you got one or two of those, they would not be real numbers. So you definitely could possibly have y equals 0 here. That would be a real number. But most of them that are real you're going to have, almost all of them are going to have 2 solutions. So let's see what we do. Let's copy down y squared equals 65, or 64 rather. So what do? You want to undo squaring. What's the opposite of squaring? Square rooting. But you want to square root here and here, but you want to make sure you put the plus or minus with one side. You don't want to put it with this side with y because you're solving for y. You want to put it with the other side. It'll save you a step. Okay, and you can use this 2 here, this exponent 2 here, to remind you to put plus or minus. I need 2 solutions. Most of these have 2 solutions. That reminds me to put plus or minus here. So let's take a look at this. This side over here is really the square root undoes the squaring, so we're just left with the y on this side. Equals plus or minus. 64 we can break down. It's even, so 2 goes. 64 divided by 2 is 32. 32 is even, 2 goes. 32 is 2 times 16. 16 is even, and that's 2 times 8. 8 is even, that's 2 times 4, and 4 is 2 times 2. So how many 2's do we get as our roots? 1, 2, 3, 4, 5, 6. 6 2's. 1, 2, 3, 4, 5, 6. So we have plus or minus the square root of these 6 2's. So how do we deal with that? Well, one way to deal with it is to know that 2 of the same inside the square root comes out as a single 2 here. These 2 come out as a single 2 here. These 2 come out as a single 2 here. And we don't have an odd 2, so we don't have anything left inside the square root. Or we don't have another number like 3 or 5, so there's nothing left in the square root here. You can also think of this as 2 times 2, which is 4, and then say, what's the square root of 4? 2. 2 times 2 is 4. The square root of 4 is 2. 2 times 2 is 4. The square root of 4 is 2. Ever what works for you. So we get, here we get plus or, on this side we get plus or minus 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. And then we have a plus or minus right here. So Alex wants us to separate those two solutions. So doesn't matter which one you write first. They've already given us the y equals. So I've written it -8, 8. You could have written it as 8, -8 if you wished. Anybody have any questions on this particular problem? So let's go on. Let's look at this particular problem. Now, solve v squared equals -121. I'm a little suspicious about this negative. Why am I suspicious about this negative here? Because what are we going to do? We're going to take the square root of this, and then we're going to have plus or minus the square root of a -121. What happens with right here? What happens with that negative number inside the square root? Okay, so we went from, here's our original problem. We took the square root of both sides. So we get the square root of this guy, which is the square root of v squared right here, equals plus or minus the square root of -121. This negative, really you can replace by -1. What's the square root of -1? Can anybody tell me what the square root of -1 is? Can anybody unmute their mic and tell me what?
Is it I?
It is I. So you're going to get an I on the outside. Now, once you get an I on the outside, is this a real number with I on the outside, or is it a complex number that is not real? The answer, it's a complex number that is not real. So once you get that I, you know, in this context, in this problem, the answer is no solution. So you really don't have to go any further. Does that make sense? If you wanted to go further, you could, but this is what would happen. This square root of -1 here is I. Square root of 121, it's 11. If you just keep taking 10 squared is 100, that's getting close to 121. 11 squared is 121. You could do 11 times 11 on your calculator. 11 times 11, 121. So since 11 squared is 121, you could think of the square root of 120, or you could think of that if we took the square root of both sides, we would get the square root here, which would give us 11, and the square root here is 121. So the square root of 121 on this side would be equal to 11 over here. So you could put that inside there. Or you have that inside there. So what is the square root of 121? And oh, by the way, you could go to your calculator as well. on the TI 84, where's the square root at? It's in the very first column, and please bring your calculators to class so you can actively participate. It's in the first column above the x squared button. So my square root sign is in blue. Yours may be in a different color above the x squared key. So I have to click the blue button, the second key in the first column, and then the x squared to give me my square root symbol. So the square root of 121 here, 121 I'm typing inside, I get 11. So you can take this out, replace it by 11, save yourself some work, not having to deal with that. And we write it in this order. Instead of writing plus or minus I times 11, we usually write it plus or minus 11i. And then you can break off the plus one, which is 11i, the minus one, which is negative 11i. These are not real because they have the imaginary unit in them. So,
Right.
yes, does that make sense? So because they're not real, and because Alex is saying, solve this where v is a real number. We found numbers, but they're not real. We have to choose the answer, no solution. And Alex gives that to you. You just click on that and it will automatically type in no solution for you, so you don't have to type in all those letters. Any questions on this particular?
Okay.
Yes.
Sorry. Just to
Yep.
clarify, so anything that has an I or any sort of like imaginary non-real number, that's a no solution for this type of problem.
Yes. Yes. So
Okay.
you get this -1. That's an issue. If you're taking the square root of a negative number, that's an issue. They don't
Okay.
exist as real numbers.
Okay. So like even if we were looking at a problem just right off the bat and it's the square root of a negative number, you're like, no
Yeah.
solution.
So like if it were the square root of -1000, no.
Okay.
Okay. If we were only asked to find real number, and it would have to say where like some variable is a real number. Do you see what I'm saying?
Yes, ma'am.
Okay. Any other questions? Anybody have any other questions, comments? Okay, let's move on. So let's look at this particular question. Solve x squared equals 54, where x is a real number. Now, this doesn't have a negative sign in front of it, so we know we can likely solve this one, okay? So, has no negative in front. It's just x squared equals 54. So copied it down. Takes opposite of squaring is taking the square root. So let's take square root of both sides, but let's put plus or minus with the side that just has the numbers. So the square rooting undoes squaring, so we just get x here, and equals. We want to break 54 down, and I remember from my way back when I memorized my times tables, 54 is 9 times 6. But if you don't remember, you could start with 2. Doesn't matter. You'll get to the same roots. You'll get the same answer. Or you might not get to the same roots, but you will get the same answer, trust, if you do it correctly. So 54 is 9 times 6. 6 I can break down into 2 times 3. So I'm going to take out this 54 and write it as the product of the roots, which are 9, 2, and 3. 9, 2, and 3. Now what's the square root of 9? It is 3, so you can take that out. 2 is a prime, 3 is a prime. We can't break them down. The only way we could break them down is into the number in itself, 2 times 1 and 3 times 1. So there's nothing we can do. So we leave 2 and 3 underneath the square root sign, and we multiply them out to get 6. 2 times 3 is 6. So we're left with x equals plus or minus 3 root 6. And Alex wants us to separate, if more than one solution, separate them with commas. So I'm going to take the positive one, the one with the plus sign in front, we don't have to write the plus sign in and just write it as 3 square root of 6, comma, because they say to, Alex says to separate with commas. And then the next one is negative 3 root 6. So anybody have any questions on this particular question? This is the last question in the objective on quadratic equations, which is due this Thursday. Anybody have any questions on the questions that we looked at today in this particular objective? So let's start the next objective. So this one has some application problems in it. So I would really encourage you to try to get as much of this done before the weekend so you have a chance to seek help. I know I've got my office hours posted for this, virtual office hours posted for this class in Canvas. We saw where to see that today. So I would encourage you to work on this as early as you can. So this is our 5th objective on radical equations. So in other words, there's going to be a square root in these equations. And how do we handle that? But the first few topics are from the past objective on quadratic equations, but I put them in this objective instead because I wanted you to master the previous objective first. So let's look at this. Solving a word problem using a quadratic equation with irrational roots. Irrational numbers are non-terminating, non-repeating decimals like pi and the number e. So they go on forever and ever, they have no pattern to them, and they don't stop. They go on forever and ever. So let's look at this particular problem. A model rocket is launched with an initial upward velocity of 57 meters per second. And it's launched off the ground. There's a picture we will see in a few moments. Oh, we're starting to see the picture now. The rocket's height in meters after t seconds is given by the following. The height, h is the height. We typically in math like to name variables with the first letter of what they stand for. For instance, h for height. That's not always done that way, but that's what we try to do. So the rocket's height, h in meters after t seconds, is given by the following. So t is time. So this one helps us remember h is height, t is time. Find all values of t for which the rocket's height is 29 meters. Round your answer or answers to the nearest hundredth. Now this rocket is getting shot up from on the ground. So it's starting on the ground, it's going up. Quadratics have parabolic shaped curves. Okay, so it's going up, it's reaching its turning point, comes back down, and you really have like an in some sense, if you know what a parabola, you're having an upside down parabola here. It's got a parabolic path that it's going through. So it goes up, reaches its height, and comes back down. So let's say here's the ground. Let's say right here is the 29 meter mark. So it's quite possible that this rocket will go through. So this is the 29 meter mark. It's quite possible that this rocket goes and hits that 29 meter mark on the first as it goes up, but it's also going to hit the 29 meter mark on the way back down. So there's quite possibly, and it turns out that there are two solutions to this problem. And also, this indicates right here, this exponent of 2, that there's likely 2 solutions. Not guaranteed, but likely. So let's see what we do. Find all values of t for which the rocket's height is 29 meters. So h is 29. So I'm going to take 29. We're going to take 29 and plug it in for h. And then we want to find all values of t. So we have to leave the t's for now. So here you notice that 29 got plugged in for h on this side, and we got this. So let's go ahead and solve this. Now, it may seem like more work at first to move these guys. I want a leading coefficient, and the leading coefficient is going to be the number in front of t squared, t to the highest power. I want a positive one. I do not like to work the quadratic formula with a negative a. Why not? Because I have an a in the denominator, and it gets confusing how to deal with that in plus or minus. Okay, so I don't want to do that. So I'm going to take and move these guys over to the other side. The opposite of positive 57 minus 57. And then, of course, t's. The opposite of minus 5t squared, positive 5t squared. So I'm going to do this, what I did to this side, we need to do to this side. And what do we get? We want to write in descending power order so we get our a, b, and c identified correctly. So we want to write the term with the largest exponent on it, the term with the largest exponent first. So we want to write this 5t squared first. And then we want to write the term with the t second. And then we want to write the constant term last. Equals. These cancel, we are left with 0 on the right side. So this allows us to identify our a, b, and c correctly. A is the coefficient of this term, which is 5. B is the coefficient of this term, which is negative 57. C is our constant, which is 29. And we only can use this, the quadratic formula, only because we have a quadratic equation. We must have a square term. We may or may not have a t term. We may or may not have a constant term. That's the only time you can use the quadratic formula, is when you have a quadratic equation. So here's our quadratic formula. T equals negative b. T equals negative. B is negative 57. So that's why I've got this negative 57 here. The first negative came from our formula. The second negative came because b is a negative 57. Plus or minus the square root. B is negative 57. Put it in parentheses because you want to make sure you get the correct sign. You want negative 57 times negative 57. This 2, that exponent of 2 means you want 2 of these multiplied together. And if you didn't write in the parentheses, you might say it's negative 57 square. You might call it negative, let's see, negative 3,249, which is not the correct answer. It's actually positive. So let me take a little drink. Okay. So getting back to what we were talking about here, it's very important that when you put b in here, you put parentheses around it and square it. I do it when b is either negative or positive, so I'm in a routine. I don't want to miss putting parentheses around it if there needs to be the parentheses there. And for me, even after teaching, going to graduate school a long time ago and teaching math, I still am a creature of habit. I want to ensure I get it that I'm accurate. So I put notation in when I know it's going to make, the chances are good that it's going to make me be more accurate. So we get that this minus comes from the quadratic formula. The 4 comes from the quadratic formula. A, 5. Then there's a C, 29. All over what? 2 times A, 5. So now what I like to do is I just like to work inside the radical here and figure out what that is. Okay, well, I guess you could do it all in one fell swoop, but you can also break it down. So if you did this, negative 57 squared, you'd get 3249 minus, now you might want to do 4 times 5 times 29 and get 580. And then you could take and do this subtraction and get 2,669. Where does that leave us now? That leaves us with 57 plus or minus square root 2669 over 10. Alex wants their solutions split apart into the one with just the plus sign and the one with just the minus sign. So let's do that. 57, we're just going to do the plus one first. The one I'm going to cover the minus sign up, and we're going to get 57 plus square root of 2669 over 10. And that's what we have here. Okay? And then we're going to cover the plus sign up and do just the minus sign, and we get 57 minus the square root of 2669 over 10 as the other solution. Now, what does Alex want? Alex wants us to do what? Alex wants us to find all values of t for which the rocket's height is 29 meters. So we're looking for values of t. What is t in this problem? What is t? T is in seconds, so it's a time. So we only can talk about positive seconds. It wouldn't make sense in this problem to even talk about 0 seconds, let alone negative seconds. So keep that in mind. We're looking for positive seconds. So how do I handle this? Well, first of all, if you're going to put this in, you will need to put this in your calculator. When you have 2 or more numbers represented in numerator or denominator of a fraction, you have 2 or more numbers of any kind represented in either the numerator or the denominator, you want to make sure you're putting parentheses around them. Or the calculator is going to think you want it to do you want the calculator to do something else. So I put this in my calculator, and there's that square root sign that came up yet again. Okay, that comes up seemingly a lot around with the topics that we're doing. How do we get to that square root? We go in the first column of the TI-84 calculator, which is what I have in front of me, and you go, that square root is above the x squared. The square root of my calculator is in blue. They use different colors for different models and different releases of the calculator and different, production batches and whatever. So you want to make sure you're looking at the color. So the square root is above the x squared in the first column in the color blue on my calculator. That means I have to use the blue button, which is the second key, before I click on the x squared to get the square root. And then I want to make sure that I put and opened up a parenthesis. I've opened up this and I put in this and I add this and so forth. So put parentheses around these as well. So I just showed you again how to access the square root on your calculator. So that's the big calculator tip of the day, if you will. So you could do this on your calculator, this on your calculator. It's said to round to the nearest tenth. So I rounded to the nearest tenth. I got 10.87 and I got 0.53. Now, both of those are, what are we finding? We're finding t. It's in seconds. They're both positive. So both of those are answers for this particular problem. 10.87 and 0.53, and that's the way Alex wants them entered. Let's make sure Yeah, I don't have the original problem. I just wrote it down. Make sure, though, you look to see that they have t equals and that they have seconds. And all they want are the numbers with a comma between them. Any questions on this particular problem? So I'm going to go to the next problem. It's from the same topic. I'm not going to do it, but I want to explain something. A ball is thrown. This is from exactly the same topic, different questions. So this is sort of seeing the differences you can see in Alex in these different questions from the same topic. A ball is thrown from the height of 123 meters. So whatever this is, a building is 123 meters tall with an initial downward velocity of 11 feet per second. The ball's height in feet after t seconds is given by the following equation here. How long after the ball is thrown does it hit the ground? So it's thrown off this building. How long does it, after the ball is thrown, does it hit the ground? So let me ask you, what are we looking for here? How long after the ball is thrown does it hit the ground? What is the relationship of the ball to the ground when it's on the ground? In other words, what is the height of the ball above the ground? That's what H stands for. H stands for the ball's height in feet. What is the height of the ball above the ground when it's on the ground? Can somebody tell me? What is the height of the ball on the ground? What's the height above the, what is the height of the ball above the ground when the ball is on the ground? Does anybody have an idea?
Would it
What
be
do you-
0?
It is definitely 0. That's what I'm getting at. So we would want to plug 0 in for this height up here. And then we would be talking about this and solving this. Now, this problem is different than the other one because we weren't throwing something up off the ground. It's likely, and then it was following a parabolic path where we got 2 solutions. There's likely only one solution to this problem. So we put in 0 for the height and we get this. And I'll just go over this from a process point of view. And then I moved everything to the side, and that changes all these signs. This will change to plus, plus, minus on the other side. 0 will get moved over here. And then identify the A, 16, B, 16 here. B is 11, and then the C, the constant, is negative 123. And then I plug them in. And I do all of this, work with the Radican, and then I get to this, and then I separate them with just the plus 1 here and the minus 1 here. And I go to my calculator and figure these out. Okay? Now, what are we looking for in this problem? How long will the ball, after the ball is thrown, does it hit the ground? How much time goes by? We're looking for the t. So can time be negative? No. So we have to cross this out. So this is the only solution. It's 2.45 seconds. Okay? 2.45 seconds. And Alex gave us the t equals and the seconds. We just have to type in, or I had to type in 2.45 to get the correct answer. Now I want to make a comment here. You can put this in Alex, a negative 11 plus this. Well, it doesn't really work on this problem. Let me see. Let me go back. Let me go back to the previous problem for a moment. Maybe not. Okay, maybe we'll have to go on. We'll have to go do another one. Or did I mention Control C and Control V? Let's say you had to put both of these in, but we don't, okay? If you type this one in this form, let's say, you could Control C it, Control V it, and just change the sign from plus to minus. That's all I wanted to say about Control C and Control V. If you're familiar with that, Alex will allow you to do that, and it's very handy. But this problem wanted us to go to decimal and then so forth. Okay, let's go on. Any questions on this particular problem? So we've done one topic here, and you can see the differences. They were quite different. So let's take a look at another topic that could have appeared in the last objective, but I decided to save it for this one. So Alex is asking us to solve this equation, y to the fourth minus 10y squared equals -9. And you will notice that there are 4 solutions. Why is that? This 4 here tells us there's likely 4 solutions. Well, how in the world do you get those 4 solutions is the question. And what we are going to do is get this all on one side and 0 by itself and turn it into a quadratic equation temporarily that we know how to solve, and then go back and change it back to y's, and then we will be able to figure out all of our solutions, all 4 of them. So I just copied this over here. Let's get everything on one side since that's what we've been doing. The opposite of -9 is +9, so I added 9 to both sides. And then when I did that, I got y to the fourth minus 10y squared plus 9 on this side, -9 plus 9 is 0 on that side. Write in descending power order, very important. You want the highest exponent to come first, then the next highest, and then the constant. So how do we turn this into a quadratic equation, you might be wondering. The tip is let u be the variable portion of the middle term. That assumes that you've written it in descending power order. The middle term is this guy. We just want the variable portion only, which is this y squared right here. We want to let u be equal to the variable portion, so u equals y squared. So this is what's going to allow us to temporarily turn this into a quadratic equation that we can easily factor. Now, next tip, square both sides. So we want to take this and square both sides. So we get u squared over here, x squared, or sorry, that's y. We get y squared. So we took this u right here, and we squared it down here, okay? We squared it down here. And then we took y squared and squared it right here. U squared is u squared. Y squared really means we have, you can look at it from an exponent or power point of view. If you have a power raised to a power, you multiply the exponents. That would give us 2 times 2, which is 4. Or you could look at this as, hey, I need 2 of the base. 2 of what? 2 of these y squareds multiplied together. But each y squared is y times y. Then we have another y times y. So you're going to get y to the fourth, if you look at it that way too. So what do? Now we have these 2 relationships between u and y. U equals y squared, and u squared equals y to the fourth. So we're going to go back to our original equation here and plug in what we can. Y to the fourth is equal to u squared. So we take out this y to the fourth and we replace it by u squared. And we get this. Minus 10, that coefficient is staying, minus 10. And now y squared We've got a y squared here, and what do we put in for y squared? U. We're changing this. We're not really we're really making this an equation in terms of u now. So we take out the y squared and put in a u here, and then that goes there, and then plus 9 equals 0. And now what that did for us is it turned out that turns it into an equation right here of u squared minus 10u plus 9 equals 0. Luckily for us, the leading coefficient is an understood 1. So we're looking for two numbers that multiply to give us 1 times 9, which is 9, and add to give us negative 10. So 1 times 9 multiplies to give us 9, but it adds to give us 10. We want negative 10. So all we do when we want the opposite of the number is we change the signs on these numbers over here. This one becomes negative. This is positive becomes negative. So is this. This is positive becomes negative. So we get negative 1 times negative 9. Definitely multiplies to give us positive 9. And when we add those two numbers together, we get negative 10. So we want to use these two numbers. So by FOIL, what's in these first two spots has to multiply to give us this. So u times u gives us u squared. So we have no choice but to break this down and use u here and u here. And then we take our minus 1 and put it in the first, put it in here. And then we take our minus 9 and put it in here and copy over equals 0. Then we set each factor equal to 0. And there's an understood multiplication sign here. U minus 1 equals 0, u minus 9 equals 0, and solve for u. If we bring this minus 1 to the other side, it's going to appear as a positive 1, so we get u equals 1. Here we bring this over here, it's going to be positive 9, plus 0, we get positive 9 on this side. So we get u equals 1, u equals 9. But we don't want the answers in terms of u, we want the answers in terms of y. Our original problem was given to us in terms of y. So how are u and y related? Right here, u equals y squared. U equals y squared. So I took out this u, put in y squared. Took out the u here, put in y squared. So now we're looking at solving y squared equals 1 and y squared equals 9. So we can take the square root of both sides, which we just looked at a little bit ago. Square root of this side equals plus or minus the square root of this side. So y equals plus or minus the square root of 1, which is 1, and negative 1, because we have to have plus or minus. Here we take the square root of this, plus or minus the square root of 9. What's the square root of 9? It is 3. And negative 3. Well, we have to use that. The square root of 9 is 3, but we need to use a plus or minus in front. So we get plus 3 and negative 3. Anybody have any questions at all on this problem? Very important that you get the idea about substituting. We don't have to use u in mathematics to do that. We could, in theory, use any letter we want of the alphabet, but we tend to use u when we do substitutions like that.
Okay, but where did you get the u? Like, where did that, I know that came into play up at the top, but I don't understand why.
Right here. Let u be the variable portion of the middle term. That's because that's what works. So the middle term is right here. This is the middle term. One in the middle. The variable portion is y squared. You really can't separate the square from the y. So you have to use it as y squared. Does that make sense?
No.
Okay.
Like, I'm just not understanding. Like, I
Okay.
have all that written down and all the steps. I'm just not understanding
Okay, well,
it.
okay, so let me see if I can get you to understand it. We can't work the problem like this. It's too complicated.
Okay.
Okay, so sometimes in math, what we do is we let u be something to see if we can turn it into u be what? You could be u, it could be t, it could be v, it could be, your favorite letter in cursive, whatever. You could use whatever you want it for you. It doesn't have to be you, okay? You could use whatever you want, but what works and what we know works in math is to when we have a quartic like this, the fourth degree equation like this, we know what works is and we have this type of equation. We know that picking whatever your favorite letter is, you can't pick Y though, because it would be confusing. You could pick whatever your favorite letter is for this. It doesn't matter. It just knows that we know that this works. We let U be the variable portion of the middle term. The middle terms are added. So this is term 1 plus, this is term 2 plus 9 is term 3. The middle term. And it's got to be written in descending power order, like this is. The middle term is right here. The variable portion. The variable means there's a letter in it. Okay, variable, this Y stands for some real number. We don't know what it is. It varies. It can vary. So it's a variable portion.
Okay, so you're basically just substituting a simpler term to make the equation work.
You're just
Where
basically,
you can solve it.
You are just using a variable to make it simpler to solve. Yes.
Okay.
And I'm glad you brought that up. Does that make more sense now? Because
Yeah, because I was like, I wrote down everything on the side and I'm like, this makes no sense to my brain, but looking at it, okay, now it makes more sense. So you're basically factoring out like Y squared to simplify the equation in order to solve it. All not factoring out, but you're kind of taking it out to make the equation more simpler.
So you get to here and you understand why I got to here, right?
Yeah.
Okay, so then the trick is to then take this right here and square both sides of that. So in other words, you put a square up here on the U.
Okay.
And then this one, if you take Y squared and square it, you're really going to get Y to the 4th.
Okay.
Does that make sense?
Yeah.
Okay, that's good. That's really good. I'm really, what is your name, by the way?
Sydney.
Sydney. Thank you, Sydney. I'm glad you hold me accountable because I want you all to learn this. And I am almost certain that others in the class had the same issue. So I'm glad you brought it up. Thank you for bringing it up. Feel free to speak out, everybody. This isn't, you've got I don't have any problems and we're not, this is one nice thing if you think about it. I've got a shy daughter, so I know what this is like. But this isn't like speaking out in a classroom. This is speaking out in a virtual classroom, which is not as maybe, it's fine. Just go ahead and do that. I just want to encourage y'all to do that. Okay, so after we get these two relationships, so let's back up to here. Then we're going to take our equation and turn it into an equation in the variable U, or whatever your favorite variable is. Obviously, you don't want it to pick a variable the same as what the original problem was in. You want to pick a different one. Okay, so where do we go from here? Well, what can we put in for Y to the 4th? Well, Y to the 4th is U squared. So we take this Y to the 4th out and we put in U squared for it. And then this minus 10, copied it down. Now what's Y squared? Now remember, we're converting everything to U's. Y squared is equal to just U. Plus 9 equals 0 just gets copied over. So that's how you go with this. And then you work it with the U's, get it down here, and then you're like, okay, I'm stuck. What do we do? We look for what is U equal to. Go back and look what your variable is equal to up here. U equals Y squared. Take out the U and put in Y squared for this one and this one. And now you've got y squared equals 1 and y squared equals 9. Take plus or minus the square root of both sides and you're done. Does that make more sense now? Sydney, does that make more sense to see how that kind of all works now that you don't have to take notes and you've heard me explain it
Yeah,
better?
absolutely. Yeah, no, it was just like it kind of just felt like you came out of nowhere and I was like, wait, where did this
I
come
can
from?
see that. And if you think I'm coming out of nowhere, please somebody ask me a question. That's what I'm here for. And that's why I've got the objectives out a little bit. So if you've got questions and we don't have time to completely finish an objective, we've got a little bit of wiggle room so I can take the questions. So I don't want to we can do a little bit of this one. I don't want to do all of it. Y'all know how to get to my notes in Alex, but can anybody tell me what I would let u be equal to in this one? In this one that's at the bottom of the screen, more at the bottom of the screen. What would u be?
It would be y squared minus 3.
Yes, the variable portion of this middle term, because when you move the 4 over, you're going to have a plus 4 over here. Y squared minus 3. Absolutely. U equals y squared minus 3. And then what was the next thing we did? We squared both sides, right? So we get u squared on this side. And let me bring this up a little bit. We get u squared on this side. And that goes, which would go down here. And then we would take this side, put parentheses around it, and square that. When I was looking over my notes this morning, I wrote that in with all these tools I have up here now. It's amazing. I discovered this summer that so much software now has tools that markup tools. So it's really nice. So that's what I did. Okay, I put parentheses around here and I squared this. Now, we want to convert this to an equation only involving u. So I've got this, okay? And what's my u squared? My u squared is equal to y squared minus 3 all squared. Well, that's the same thing on the right side here is the same exact expression as on the right side here. So that entire expression is equal to u squared. And then we move along and we see this expression. What can we do with that? That's y squared minus 3. That's right here, and all of that's just equal to u. So we take this out and replace it by u. And I've got those markings underneath to see that. So now what do we have? We have u squared plus 4. There's a 4 here. You want to keep your coefficients. You don't want to do anything with those coefficients in front. So it's plus 4 times u plus 4 equals 0. So now we get this equation. So let's look at this equation for a moment. So we're looking for two numbers that multiply to give us 1 times 4, which is 4, that add to give us 4. So this may be a little tricky, so let's take a look at this. So I start with 1 times 4, that they multiply to give me 4, but add 1 plus 4 is 5. That's not what I want. So does 2 go into 4? Yes. 4 is 2 times 2. If I add 2 plus 2, I get 4, which is what I want. So now this is going to factor into the u goes here and here. So I put one of these 2's plus 2's here, the other plus 2 there, equals 0. And you could always FOIL this out to see that this is correct. So I set each factor equal to 0, but here we've got 2 factors that are the same, so we only have to do it once. So u plus 2 equals 0. So move the 2 to the other side. It's going to end up on the other side, and we're going to get u equals -2 on that side, since the opposite of adding is subtracting. So now what do? We're stuck. We need something that relates u and y. So what relates u and y? Up here. So u equals y squared minus 3. U equals y squared minus 3. And then COV equals negative 2. So we want to solve for y. It's not too bad here. The opposite of subtracting, add. So we add 3 to both sides. We get y squared on this side. Minus 3 plus 3 is 0. Equals negative 2 plus 3 is 1. Now, we take the square root of both sides, but we need to put the plus or minus with one of the sides. What's the square root of 1? 1 times 1 is 1, so the square root of 1 is 1. Could even do it on your calculator using that square root that I showed you. So the square root of 1 is 1, and we get positive 1 and negative 1 has our answers. Now, let's just check. Are we working y's in the original problem? Yes. Our answers are 1, comma, negative 1. So I think, and my hope is, you understood more of the process now. And when Sydney asked that question and we had that little discussion, then this makes more sense to you. And you can see the different, these two questions are from the same topic. And so you can kind of see the little changes in the different questions. So does anyone have a question before we move on? Before we leave this particular topic? So let's go ahead and move on. So let's look at using the Pythagorean theorem. This is also a quadratic equations topic. Very important. I'm teaching trig, and we are going to talk about the Pythagorean theorem tomorrow in trig, and no, I did not plan that. So that's one place you will see the Pythagorean theorem if you go on to take trigonometry. Using the Pythagorean theorem, the hypotenuse of a right angle, the hypotenuse of a right triangle, that's this side here. So a right triangle has a vertical side, and you can think of it as having a vertical side and a horizontal side for purposes of this topic. And then this other side that is neither vertical nor horizontal is a hypotenuse. So we're told that the hypotenuse of a right triangle is 10 inches long. So I put 10 over here and labeled it the hypotenuse. I haven't learned to make great S's with the markup tools yet, so I'm working on it. So the longer leg is 2 inches longer than the shorter leg. Find the side lengths of the triangle. So the longer leg is 2 inches longer than the shorter leg. I really don't know anything about the shorter leg. So that's what I'm going to call X, the shorter leg. So I'm going to call that the shorter leg. What I do know is something about the longer leg. It tells me that the longer leg is 2 inches longer than the shorter leg. So I can use the shorter leg and call it X. So I now know the longer leg is 2 inches longer than X. So that would be X plus 2. That's the longer leg. And now I've labeled my right triangle. There's a 90-degree angle right here. So I'm just setting up, so one side's the vertical, one side's the horizontal, and then the hypotenuse is the opposite side. So the Pythagorean theorem, we typically use, we see it typically written in this form, a squared plus b squared equals c squared. What does that mean to us in this context? It means a leg squared plus the other leg squared equals a hypotenuse squared. So let's start with the shorter leg. We'll put X in here for the leg. X squared, you get X squared, plus the other leg. That's this guy up here, x plus 2, we put it in parentheses, square it, and get x plus 2 squared equals the hypotenuse 10 squared. So this x squared, I'm just bringing straight down, plus comes straight down, x plus 2 squared. This exponent of 2 tells us that we want 2 of these bases multiplied together. In other words, we want to take x plus 2 times x plus 2 right here. And we can FOIL because we have a binomial 2 terms times 2 terms. That's the only time you can FOIL. So we get x times x, which is x squared, x plus 2 from the outer, the O in FOIL, outer. 2, so we get x squared plus 2x, that's the outer. We can multiply in any order. Then we have the inner 2x, so we have 2x plus 2x, which is plus 4x. Last 2 times 2 is 4. So that's equal to x plus 2 squared. So I'm going to take this x plus 2 squared out, put in this over, I put in this over here, equals 10 squared is 10 times 10, which is 100. Now we want to solve this quadratic equation. It's a quadratic equation at this point. We have 1x squared, and understood 1 in front, plus another 1 in front, 2x squared, plus 4x. And then we want to move this 100 over here. So this positive 100 on that side ends up as minus 100 on this side. So we get 4 minus 100, which is negative 96. So 2x squared from here, 4x from here, 4 minus 100, negative 96 from here, equals 0. So let's go to the next page. I just copied this down right here, so we can look at this. So what are we looking for? Well, first let's factor the 2 out. I see that this is even, this is an even number, this is an even number. If you can factor the 2 out, then you don't need to deal with the leading coefficient of 2 when you factor. That's the beauty of this. So it's important. So if I take a 2 out of this term, the 2 goes out front, we have just x squared left here. 4 is, I can write as 2 times 2. 1, 2 goes out front, the other 2 stays, and get plus 2x. Minus 96, we've got minus. A 2 can go out front. If you take 96 divided by 2, you get 48. So that's what we're left with. So we've got 2 times this. We only need to factor what's inside the parentheses here. We're looking for factors of 1 times negative 48, which is negative 48. Those factors multiply to give us, the 1 times negative 48 multiplied to give us negative 48. And the factors add to give us 2. Now, I'm not going to spend a lot of time going through all of this, but I found that negative 6 and 8 work going in a very systematic approach. And negative 6 times 8 is negative 48. When you add these two together, you get negative 6 plus 8, you get positive 2. So I know these are the numbers that I want. Since we have x squared, we know we're going to have x here and here. Minus 6 goes in there. Positive 8 goes in there. And now, what are we solving for? Remember, our shorter leg is x. We're solving for x. This has these are factors. 2 is a factor, x minus 6 is a factor, x plus 8 is a factor. We're solving for x. This 2 has no x in it, so we ignore it. We're only solving for x here. So x minus 6 equals 0, x plus 8 equals 0, and then we're going to add 6 to both sides, so we end up with x equals 6. We're going to subtract 8 from both sides and end up with x equals negative 8. But what is x? It's the length of the shortest side, so we can't have that be negative. We have to have a positive length, so we can't have this as our length, this is our length, yeah. We can't have this as our length, so we have to cross it out. It's negative. Okay, so we know x is 6. We know that the shortest side is 6. So let's go back up here. Length of the shorter leg is 6. The length of the longer leg is x plus 2. Well, we know the length of the shorter leg is x, and that turned out to be 6. So we plug 6 in here for x, plus 2 is 8. So the length of the longer leg is 8. We were given the length of the hypotenuse. It's 10. So those would be our answers, 6, 8, and 10. Does anybody have a question on this particular example? Anybody have a question? I'm just making sure I'm checking when our class ends at 1:50. So let's talk about solving a radical equation. A nice welcome break, I think, from the application problems that we looked at. So you might want to jot down this process. Take a couple minutes to jot it down. Very important process. It's really you need to check. It's a very, very, very important. Check all possible solutions here. So I'll give you a minute or two to write that down, the process. You don't need to copy the topic numbers. That just helps me to know if I'm doing 2 questions of the same topic, basically. So that's more for me than it is for you. Okay, so let's take a look at a question or from a topic. We're going to start slow and then work our way up.
Can you go back for like a split second? Do you mind?
Oh, to page 9? Okay. Page 8, you mean? This solving rational equation? Is this where you wanted to go, Sydney?
Yes, I just needed a minute to finish copying the last one.
Okay. I think it's important to copy the processes down so you can follow what I'm doing. And
all right, thank you.
you're welcome. Anybody else need more time? Let's go and take a look at this. So we're going to start off slow here. We may not use all of our steps in our process for the first one, but we will before we're done. So we want to solve for u. We want to find the number we plug in for u, subtract 13, take the square root, and have it be equal to 8. That's what we're looking for. So our first step, isolate the radical. Now we're lucky that the radical's on one side by itself. That's what isolate means. Get the square roots on one side by itself. And we already have that done for us. So I just copied it down. The next step, square both sides. So I put this side in parentheses and I squared it. And what we do to one side, we have to do to the other. So I squared the 8. And why do we square it? Is because squaring undoes square rooting. So we're just left with this cancels this in a sense. And then we're just left with the radicand, which is u minus 13. Equals 8 squared. 8 times 8 is 64. You're welcome to use your calculator to find that out. And now just to get u by itself, we need to undo subtracting by 13. The opposite is addition, so add 13 to both sides. We get u. Minus 13 plus 13 is 0, so we get u plus 0 is 0. So we get u on this side equals 64 plus 13. 4 and 3 is 7. 6 plus 1 is 7. So we get u equals 77. So Now what we have done is the radical was isolated. We did square both sides, we did solve, and we now need to check. So we're doing 3 of the steps. Check in the original equation. Here it is. The original is right here. We plug in 77 for u. 77 minus 13 we get then inside the square root. 77 minus 13 turns out to be 64. The square root of 64 is 8. And got 8 on the left side here. E does equal 8 on the right side. That is definitely true. So that means our solution is u equals 77. So that u equals 77 is what goes in the box, the Alex box. So let me just, anybody have any questions on the first one that we did? Starting off, just basic, more basic here, we did 3 of the steps. We didn't have to isolate the radical. So let's move on. Let's take a look at this topic. Now you will notice this radical isn't on one side by itself. We have -1 outside the radical. So I just copied down the problem here. First step, isolate the radical. That means we want to deal with this -1. The opposite is adding 1 to both sides. Well, the opposite of subtracting 1 is adding 1, and what we do to one side, we want to do to the other side. So let's add 1 to both sides. Get 1 plus 1 is 2 here. Square root, -1 plus 1 is 0. That's adding 0 isn't contributing anything, so we don't write it down. So now we are at this point to step 2 of our process, squaring both sides. So we want to undo square rooting, so we want to square this side, but we also have to square this side. So that's what we did. We squared both sides. So 2 squared means we have 2 2's multiplied together. 2 times 2 is 4. The square undoes the square rooting. So on this side, we're just left with 4w minus 16. So now we want to solve. We want to continue to solve. So we want to, the opposite of subtracting 16, add 16 to both sides. 4 plus 16 is 20. Then we have equals 4w minus 16 plus 16 is 0. 4w plus 0 is still 4w. Now to get w by itself, we have 4 times w. That's multiplication. The opposite is division. So let's divide both sides by 4. 20 divided by 4 is 5. 4 divided by 4 is 1 times w is w. So we get w equals 5. Check in the original equation. So here's the original equation. We want to put 5 in for w right here and get this, and everything else is the same. So 1 equals square root of 4 times 5 minus 16 minus 1 on the outside here. And the question is this true or false? So let's look inside the square root. 4 times 5 is 20 minus 16 is 4. And then bring this minus 1 down. And then we get square root of 4 is 2 minus this 1 is 1. So we get 1 on this side equals 1 on this side, which is obviously true. So our w equals 5. So Alex will want you to type in the 5 up. Let's just see. Up here, they give you the w equals, and I just typed in 5 and got my answer correct. So any questions on this particular topic? So let's see what we've got in store now. Let me just take a quick peek at this. This is one like you could see on your first test. So let's do this one and end there today, and please ask questions. So 7 of your written work. So each test, I'm going to give you 7 written work topics that are going to be on that test. That includes the final 2. The first 3 tests and the comprehensive final, I will give you 7 topics that you are going to C. And I will go over those the class period before the test. So our test is 2 weeks from Thursday, our first test. So on that Tuesday, I will go over those topics with you. That's the way I'm going to review. The other part of the review is up to you, and we'll talk about how you can best do that a little later. So this is one of the ones that you will likely see. And let's go over this. Let's start from first isolating the radical. Now, this radical is isolated. It's all by its lonesome on the right side. So I just copied this over y plus 2, and then this radical, and then I realized the next step was to square it. So I squared each side. Okay, so I know the squaring undoes the square rooting. So I cross this out, cross the square out, and cross the square root sign out with this little slash here. This is the binomial. This 2 means 2 of these y plus 2 multiplied together, and we FOIL y squared, check. Outer 2 is y times 2, but you can write it as 2 times y. Inner 2, 2y. Last 2 times 2 is 4. After the square root undoes this, or after the square undoes the square root, we get negative y plus 18 on this side. So we want to get everything on one side, and we want a positive leading coefficient. So that highest power term is this square term here. So let's move these guys. Opposite of subtraction, addition. Opposite of addition, subtraction. So that will give us this, and we had to do that on this side too. You see a plus y here, minus 18 here. That will give us a 0 on this side. It will give us a y squared. 4y plus 1y is 5y. 4 minus 18 minus 14 equals 0. Now, what are we looking for? Luckily, our quadratic equation has a understood leading coefficient of 1. So we're looking for 2 numbers that multiply to give us 1 times negative 14, which is negative 14, and add to give us 5. Negative 1 times 14 is negative 14, but when I add those 2 numbers together, negative 1 plus 14, I get 13, not what we want. 14 is even, so a negative 2 goes. Negative 2 times what? 7. Just to check, negative 2 times 7 is negative 14. But when I add these guys together, I get negative 2 plus 7, which is 5, which is what I want. So I want these 2. Now, because the leading coefficient's understood to be 1, I know I could put y. We know we can put y here and here. We put one of the numbers in the first factor, the other one in the second factor. It doesn't matter which one you put in first. And that's equal to 0. Now by the product property of real numbers, and we know that each one of these stands for real numbers. Each one of these factors stands for a real number. The only way we can get a product of 0 is if one of them is 0. So we set each factor equal to 0. Y minus 2 equals 0. Y plus 7 equals 0. We solve for y. Add 2 to both sides. We get y equals 2. Subtract 7 from both sides. We get y equals negative 7. Now we want to check these guys. We want to check our possible solutions. These are possible solutions at this point. No guarantees whatsoever. Let's check y equals negative 7 first. Now, let's go back up here for a moment. And we're checking y plus 2 equals, I'm going to write that down. Y plus 2 equals the square root of negative y plus 18. So we go back down here. So this right here is a y in the original equation. We put negative 7 in for y. Plus 2, that's in the original equation, equals square root of a negative. That's in the original equation. Then there's a y, but y is -7. We're checking y equals -7. Plus 18. -7 plus 2 is -5. Negative times negative is a positive. 7 plus 18 is 25. We have the square root of 25 here. Now the square root of 25 is 5. So on this side we have -5. On this side we have +5. They're not equal. So the answer is false. This doesn't work in the original equation. It's just by the process of squaring, it came up, but it doesn't work. So when you square, it's not whatever you get for your variable isn't always, whatever numbers you get for your variables isn't always going to work. So you got to check. So the only solution in this case is y equals 2. When we check y equals 2, we have a y in the original equation, so I put in 2 plus 2 gives us 4 equals. We have square root of a negative. Then there's a y, but y is 2, so that goes in, plus 18. So 2 plus 2 is 4. 18 minus 2 is 16. Square root of 16 is 4. 4 equals 4 is true. So there's only one solution to this problem, and it is y equals 2. Any questions on that particular problem? I'm just making a little note. Anybody have any questions in general about the course? I think that, yeah, I think we have enough time to go over this one. You can see it's really, compared to what we just did, it doesn't look too bad. So let's take a look at this one. Solve the following equation for D. Just make myself a note. Okay. Well, all we need to do is solve this for D. Just take and solve it. The first thing we definitely need to do, and I copied it down here, is move I don't know why I copied it down twice. I don't know, I have a clue why I did that, but I did. So the first thing we need to do is move this 3. This 3 is participating in multiplication, so we need to divide both sides by 3. That's what I did. 3 divided by 3 is 1 times square root of D is square root of D. 1's a multiplicative identity. That's why we can do that. So now we get T over 3